Hello, this is Dr. Joe Trout from the physics program at Stockton University. And in this lecture, what I'd like to do is summarize what we've been talking about for the past few lectures, and also fill in some missing information that you might need. So we've been talking about the evaluation of student learning, and the assessments we use are used to identify individual students' weaknesses and strengths, and to guide in the development of courses and advancements in teaching strategies, and to identify the need for specialized academic support or educational programs or social services. So when students are assessed, it's not only to find out what the students have learned, but also to help in guiding the rest of the course or other types of instruction. And we mentioned that the major types of assessments are high stakes assessments, pre-assessments, formative assessments, summative assessments, interim assessments, placement assessments, and screening assessments. So high stakes assessments are assessments with significant consequences for students or teachers or schools, such as standardized tests determining advancement. So for example, the United States Navy has a lot of highly technical jobs in it. And to reach the next rank, enlisted people must take standardized tests to see how much they know about their particular field. So the outcome of this test is one of the things that are used in deciding whether they are advanced to the next rank or not. There's pre-assessments. So pre-assessments evaluate the student's prior knowledge and skills before instruction to inform teaching strategies. So normally on the first day of any class I teach, I give a pre-assessment test to see where the students are. This is especially helpful in G courses where students are coming from separate majors and have different abilities. So it helps to guide the timing and the depth of the class. It's also formative assessments. So this is ongoing feedback to improve learning and teaching during the instructional process. So there are ongoing assessments during the learning process, and they provide feedback for improvement. So some examples are quizzes or class discussions or draft submissions. In my classes, I like to use in-class worksheets, and they tell me where the students are, and they help me guide me in teaching the course. There's summative assessments. So these evaluate the student to learn at the end of a course or unit, measuring outcome against standards. So they evaluate students' learning at the end of an instructional period, for instance. So this could be a final exam. And they measure outcomes against standards or base marks. So examples are final exams or end of term projects or standardized tests. So for example, in my weather and climate G course, the students do a final paper where they look at temperature data for 100 years at 2 locations around the world. And the idea is that they use everything that they've learned during the class to talk about the climate of the 2 areas that they're given. There's interim assessments. These are periodic evaluations during instructions to monitor progress and guide future teaching. So, for example, some people give weekly or daily quizzes to students. There's placements assessments, and these determine appropriate starting levels for new students based on their prior knowledge and skills. So maybe you took a test to see where you would begin your education in mathematics, right? To see if you're going into pre-calculus or calculus, for example. There's also screening assessments. So these are assessments that identify students' initial abilities and need for before instruction begins, guiding their tailored support. We also talked a little bit about assessment design, and we'll talk more about this, but just to summarize what we've talked about so far, we talked about standardized assessments, standards reference-based assessments, common assessments, performance assessments, and portfolio-based assessments. So for the standardized assessments, these are uniform tests administered and scored in a consistent manner. So they measure the student's performance against a standardized benchmark or norm. So some examples are SATs or ACTs or standardized achievement tests. There's also standards referenced assessments. So these evaluate student performance based on predetermined learning standards or objectives, and they focus on the mastery of specific skills or knowledge. So some examples are state assessments that are aligned with academic standards and competencies-based assessments. For common assessments, what this is are assessments that are used across multiple classrooms. So we don't do it at Stockton, but I've been at physics programs at other universities where every student got exactly the same test. And in fact, they took all of the sections and put them in a large room and gave them the test at the same time. So this ensures consistency in evaluating student learning within a given curriculum or program. One of the reasons we don't use it here is because it also limits the professors in their from varying their teaching techniques or from trying new teaching techniques. Some examples are district-wide benchmark assessments or common end-of-unit tests. It's also performance assessments. This requires students to demonstrate knowledge, skills, and abilities through authentic tasks or activities. So they emphasize application and transfer of learning into real-world contexts. So for example, some of these examples of these are presentations or projects or experiments or simulations. There's also portfolio-based assessments. So in this case, what we do is collect all the student work, or at least samples of all the students' work that demonstrates their growth and achievement and learning progress. So it'd be a collection of maybe your highest test scores or your best papers that you've written or some projects that you have worked on, or with some evidence about that, like pictures and a summary. So they provide a holistic view of student performance and development. So some examples of these are digital portfolios or just a physical collection of projects and assignments. You'll find that if you go to work for industry, A lot of times, if you're going up for a new position or if you want advancement or you put together a portfolio of all your best things that you have done, all your best projects, and present them. There's a few more tests or assessments, or at least a couple other different words that are used that I'd like to talk about. So for example, there's diagnostic assessments. You'll hear that word being used. And these are conducted before instruction begins. And once again, it identifies the student's pre-existing knowledge, skills, or needs. So these pre-tests are initial skills tests or reading inventories. So you'll also hear them, like I said, hear them called diagnostic assessments or norm referenced assessments. So this are the SATs or ACTs or IQ tests, and they compare a student's performance to a group norm, and they determine a student's ranking within a group. You'll notice that many of the assessments that you take could fit into several of these groups. There's criterion reference assessment. So this measures a student's performance against a fixed set of criteria or standards. And it focuses on whether students have learned specific skills or concepts. So a good example are driving tests or end of unit tests. So another word you might hear is norm referenced assessments. So these compare a student's performance to a group norm. They determine a student's ranking within the group. Once again, the ACT or SATs or IQ tests are all examples of this. We also have assessments that compares a student's current performance with their past performance. So in this case, it focuses on personal improvement and growth. And some examples of these are the portfolio reviews. So if we keep a portfolio through your entire college career, we could review them every couple of months and see if you're improving. Also, progress reports are under the same category. There's also performance-based assessments. So these require students to demonstrate their knowledge and skills through active tasks. So these often involve real-world challenges or projects. So for example, presentations or experiments and performances. Another one we haven't mentioned is peer assessments, and these involves students assessing each other's work. So for example, in my electronics course is a writing course, and the students will have to do formal lab write-ups, and they make a rough draft, and then they exchange it with another student, and that student evaluates their lab report and gives them some suggestions to help improve it. So this encourages collaborative and critical thinking. So some examples are peer review or group evaluations. We also have self-assessments. So every year, the physics program does a self-assessment. And what it does is we go over and evaluate our program. So this encourages, for students, it encourages students to reflect on and evaluate their own learning. And it promotes self-regulation and autonomy. So some examples of self-assessments are reflective journals and self-evaluation checklists. And we mentioned this word before, authentic assessments. And this evaluates students' abilities in real world contexts. So it focuses on practical applications of skills. So for this, there's things like internships and community projects and simulations. So for example, my Physics 1 class, instead of me doing the demonstrations for it, I teach groups of students to do the demonstrations and they teach the class. And then we bring in an outside group like a high school or a grades or seventh or eighth graders, and they do the same thing for these students. So they teach them about physics through the demonstrations. So this is a good community project, and it also helps them learn some more about physics. We also talked a little bit about scoring and statistics. So first we talked about the average, right? And the average is just the sum of the scores divided by the number of scores. So for example, if your homework scores were 98 and 66 and 90 and 99 and 87 and 23 and 55, we'd add them all up and then divide by 7, because there's 7 homework scores here, and end up with 74. We also talked about the median, and in the median, what you do is you take the list of numbers and you put them in order. So 23, 55, 66, 87, 90, 99, and 100. And if there's an odd number of test scores or samples, what you would do is take the middle one. So there's 3 lower than 87 and there's 3 higher than 87. If there are even numbers, what you would do is take the average of the middle 2 numbers. We also talked about standard deviation, and we said, in essence, this is a measure of how far the different samples or test scores are from the average. So in order to do the standard deviation, what we do is take your test minus the average test score, right, and square it. And then we do that for all the students. So there's n students. And then for a small population, we divide by n minus 1 and then take the square root. For large populations, it actually becomes the average of this, right? So we take your test score minus the average, square it, and add up all of these for all of the students, and then divide by the number of students. So generally, in this case, we found the average. So we get 23 minus the average and 55 minus the average and 66 minus the average. We square those values so they're all positive. Then we add them up and divide by 7 minus 1, or 6. And then take the square root, and that gives us the standard deviation. So this tells us how the scores vary according to the average. There's also something called weighted averages, right? And for example, let's say a syllabus says that homeworks are worth 10% and quizzes 20%. And there's 2 midterms and they're 20% each, and a cumulative final. And this gives us up to 100%, right? So we have 10% plus 20% is 30%, plus 40%, because there's 2 midterms, is 70%, and then 30 for the final is 100%. So in this case, what we would do is let's say you got your homework grade was 100, so it was perfect. Then your quiz grades average was 95, and you got an 85 and a 75 on the midterms, and an 85 on the final. So then The homeworks are worth 10%, that's 0.1. The quizzes are worth 20%, that's 0.2. And then the midterms are worth 20%, that's 0.2. And finally, the finals worth 30%, which is 0.3. And we end up with 86.5 for your final grade. Getting back to the standard deviations, what we find is that if we so many times, if we have a large number of scores, we get something that looks like a bell-shaped curve. And what these average and what the standard deviation shows us is how many students are within that section. So for example, if I look at one standard deviation from either side of the mean, then 68% of the students are within that one standard deviation on either side of the mean. If we go 2 standard deviations, we're up to 95% of the students. And if we go 3 standard deviations, we're almost at 100%. So for small classes, this might not seem so obvious. But for example, here's some test scores from a class of about 500. And you can see that it pretty much follows this bell-shaped curve. This is called a histogram. And what it shows is the frequency, in this case, the number of students and their scores. And they're binned by, so for instance, the first one is the number of people with scores between 15 and 20, and then 20 and 25, and 25 and 30. So we have this, we end up with a curve that looks like this. And we can tell that in this side shows the percentage. So 50% of the people, right, were at 50%. So once again, this is a really large class. This is about 500 students. By the way, on this one, the average came out to be about 49.77, or really close to 50. The median was about 48, and the standard deviation was about 14. So here shows some made up test scores. And in this case, what we have is that we have an average of about 75, which is about where it should be. And we have a standard deviation of 10. And we have the lowest score is about 50 and the highest is about 100. If we look at something with a smaller standard deviation, so here's a standard deviation of about 5, and here the test was, the average was a little higher, was about 80%, but you can see that the spread in the grades are much smaller. So this is, the lowest was about 70 and the highest was 95. Where in this case, the lowest was about 50 and the highest was about 100. So this was the same number of students. This was a lower average and a larger standard deviation. This is a higher average and a smaller standard deviation. So for example, maybe this test didn't quite challenge the students well enough, right? Because the average was pretty high. Or, for example, the professor may have just been really good at explaining everything and everyone just did really well. Or it may just be a class of really exceptional students. Most of this we can do on a spreadsheet, and I'll talk about that at the very end. I also wanted to talk a little bit about curving grades. So everybody always asks if the grades are curved, right? But what does that mean exactly? So for example, let's say I gave an exam and I got a grade distribution that looked something like this. So the average was a 40 and the highest was a 70. Well, clearly, either I didn't do a really good job or the exam was just way too hard, right? And wasn't a true evaluation of what the students knew. So in this case, what we'd like to do is adjust the test because obviously it seems like it was way too hard. So we want to adjust the test. And what we'd like to do is take this distribution and center it over about 75, whatever it should be, and have it so that the highest person gets around 100. So we would like to keep the same standard deviation, but move this curve to the right to adjust for how difficult the test was. So there's a couple of ways to do this. To be honest, probably the easiest way is called the linear transformation. And this method just involves adjusting all the test scores by adding the same amount or multiplying by the same factor. So the new score will equal A times the original score plus B, where A is some scaling factor and B is an offset. A lot of times we just make A equal to 1, and suppose that the highest class score was 85, and you wanted to make 85 equal to 100, we just add 15 points to everybody. So everybody's new score was the original score plus 15. So especially with small classes where it's really hard to do anything else, oftentimes we do that. There's also a standardization or z-scores. So in this case, this method, you convert the z-scores, standard scores, which measures how the standard deviation of a score is from the mean. And then you take these z-scores and convert them back into a desired mean and standard deviation. So first, you calculate the mean. This is this lowercase mu in this case, and the standard deviation, and this is the lowercase sigma. And you convert all the scores. So you take your score minus the mean and divide by the standard deviation. And then you decide what you want the mean to be and what you want the standard deviation to be. And you take the z-score, multiply it by your new standard deviation, and add the new desired mean. We also have Bell's curved adjustments, and that's just like we were talking about when I showed you moving that graph ahead, right? So in this method, you adjust the scores so they fit a normal distribution. I have had professors who insist that all the scores fit this normal bell curve distribution. The problem with that is that it doesn't really allow for if you just have a class of really exceptional students. So this is also more complex and involves assigning grades based on percentiles. So if you want the top 10 scores to receive an A and the next 20% to receive a B, and then you can keep on going. So you can use the cumulative distribution function, or CDF, of the normal distribution to assign grades. And finally, we have rank-based grading. So this method assigns grades based on the rank order of their scores. So in essence, you sort the scores from ascending to descending order, and then you assign grades based on the position of the sorted list. So for example, the top 10% get an A, the next 20% get a B, and so forth and so on. So I wanted to talk a little bit about how we could do this in Excel. And I'm going to give you an extra credit assignment if you would like to try some of these things in Excel. So for example, let's say we had a test scores, and let's say you got a 99 and 100 and an 89 and a 92, and then you had a bad day, maybe a 50. Excel has something called functions or formulas. And what you can say is that, for example, let's say you wanted to count up the number of scores. You can see there's 5 here. But for instance, you can type count and highlight these scores, and it'll tell you how many there are. Okay. You could also do things like add up the scores. So it equals the sum, and we could highlight these scores, and it'll tell us the sum of all these scores. So if we add all these together, we get 430. You could also do calculations here. You could take the sum of the scores and divide it by the number of scores. And what we're doing is using this thing called cell referencing. So A9 represents column A, position 9. And A8, column A, position 8. But what this is the average of all the test scores. Well, to be honest with you, Excel has or most spreadsheets have a function called average. And if we highlight up all these numbers, we get the same region, right? So don't forget, this was the count. And this was the sum. And this was the sum divided by the count. Which, by the way, is just the average. We could also figure out the standard deviation. So if you remember, what we wanted to do was take our test score and subtract the average. And we want each test score to be counted, and we want the average to remain the same. So if you know a little bit about Excel, what we could do is use a fill down box, right? And we won't have to type this into every one of these cells. Once again, you won't be tested on this, but I'll give you an extra credit assignment that you could try. If you notice, some of the numbers, some of your exams were higher than the average and some were lower. In order to get rid of the negative numbers, what we're going to do is square each one. Oops. So we'll square every one of these, right? And then what we can do is add them all up. And then divide by n minus 1. So in this case, n is equal to 5, and we're going to divide by 4. And if we take the square root, this will give us the standard deviation. Of course, Excel has a function for doing standard deviation. And if you notice, we get the same answer. So Excel can do all of these things for us. And as I said, we'll give you a little extra credit assignment if you'd like to try something in Excel. Okay, well, thank you for your time.